at Google, and so she's going to talk about Android development at Google. What's really interesting about Robin and what I is that she's a black belt and she's obviously very strong, or maybe she'll tell us about that too. And so I am very honored to be able to introduce you, Robin, and I am looking forward to this talk.
Okay.
Thank you.
Slight technical. Yeah, I think we need people. That's fine. I fell in love with Android when I bought my first proper smartphone. This was 6 years ago, and I was studying for my PhD at the time. And I had bought phones before, but they were, they were those bricks. They gradually got better. And this was the time I thought, right, I want one of those phones with integrated mobile browsing and all those apps. So, 6 years ago, I bought a Google Nexus S phone. It had quite a distinctive plastic molded back. It was very durable when I dropped it on the floor, and it came with the gingerbread version of the Android operating system. I was very happy with the initial unboxing experience. New technology, new gadgets, going through the setup, irritating my neighbours with the ringtone selection, and gradually I started looking at the apps that were available on this phone. And I sort of thought, hang on, some of these maybe I could write. And so when not studying for my PhD, I took some time, looked on the internet, I was looking at Android tutorials. And gradually I felt that I'd learned enough that maybe I could start writing my first Android app. And this was 6 years ago, so the internet was a little bit younger at the time. But after due care and consideration, I decided that my first Android app would be an app for showing pictures of cats. Fast forward these 6 years, I finished my PhD and I started working at Google. I'm a software engineer and I work on Android. And I'm even working on some of those Android apps that were on my Nexus S all those years ago. But Android is an operating system built on the principles of openness. And it really is a global system. There are over 1 billion active Android devices out there. And while Android is developed at Google, we work together with a whole ecosystem of partners. So we're working with mobile phone operators and device manufacturers to build what is now more than 4,000 different Android devices. And by far the majority of these are going to be phones and tablets. But we're branching out. We're now looking at televisions, cars, and watches. And when you have Android on a smartwatch, we call this Android Wear. And my Android Wear device is paired with my Android phone or tablet. And so the idea with Android Wear is to focus on real-time, relevant information delivery. I could just be looking at my phone, but if I can glance at my watch screen and see that important piece of information, that's my amazing moment. That's what makes it better during my day. And developing for Android Wear is very similar to developing for Android, in Android on mobile. So it's still Java and XML based, but it is in fact a bit simpler than developing apps for mobile. And this is because I mentioned my watch is paired with my phone. Much of the computation I do on the watch is actually delegated back to the phone. And to some extent this is because it's a small device that has limited memory, CPU, battery life. But Android Wear really is a growing ecosystem. And so with each new generation of devices, the memory and CPU are improving and gradually become more and more powerful devices. So I told you about my very first Android app, the one with all the cats. And I really did want to tell you today about my most recent Android app, which happens to be an Android Wear app. Unfortunately, due to the launch processes at Google, my launch has been slightly delayed, and I can't talk about it today. So instead, I'm going to talk a little bit about Android, and focus on some of the talk on how you can develop apps for Android Wear and how the support libraries and the wearable APIs make writing apps for Wear a real pleasure sometimes. Plus, I'm going to talk to you a bit about the development process for Android features at Google. So, where do new features come from? Where do our ideas come from? Why are we developing this new app? We get many of our ideas from our users. We look at the Play Store reviews, the user feedback that we get for each app. There's also people at Google whose entire job is making sure that our products are doing the right thing, and these are the product managers, or PMs. And they're making sure that we're listening to our users, but also that our products are competitive, and we're doing things that are going to push Google up into the future. Also, as an engineer, if I can come up with a great idea and I can convince my product manager of it, I can be the one leading the way for what my feature's going to do. And sometimes the ideas come from the top. Sundar is CEO of Google and Hiroshi is head of Android. And if these people come up with ideas, it's generally a good idea to see what you can do with that. So we've decided why we're developing the feature. Maybe it's a great new collaboration between two existing products, or it's a really highly requested user feature. The question then comes, what does this look like? And this we pass to the team called User Experience, or UX. These are the people who make our user interfaces intuitive, useful, and beautiful. And there are many roles in UX. We have researchers and designers, interaction designers, web developers, visual designers, and writers. And all these people working to make sure that our UIs really do work for our users. So we have this kind of nebulous concept. We want to collaborate between these products. We want to create this new feature. What's it going to look like? UX are going to give me, the engineer, a really detailed technical drawing of what the UI is going to be. So it's going to be, button here, big image here, maybe a checkbox over here. I'm not UX, sorry. But it's more specific than that. Exactly which font and font size am I going to use? How big in pixels is this image going to be? And where exactly are these items correlated? So what is the spacing here? What spacing? It's a real technical drawing. And having received this and my product specification from the PM, time to start coding, that thing that I do. Except it is important to plan your design before you start. No matter how excited you are to get going, at Google we try to emphasize this planning process. We create something called an engineering design document. And in this I write down all the important parts of my implementation. So maybe if I'm doing an Android Wear app, what information do I want to share between my watch and my phone? And then what information do I need from my backend in the cloud in order to pass this information eventually to the phone? So we write this down in whatever detail is appropriate, and we send it to be reviewed by other engineers and the product manager. Product manager is checking that I haven't gone rogue, and that I'm still doing the feature I was intended to do. And the engineers are looking for holes in my design. Things, and the problems that we can identify early and the solutions that we work out now will save so much time in the future when you get to implementing. But it's okay, you don't have to switch off your IDE just yet. When you are developing a new feature, it's a great idea to make a small prototype. Because if I can prototype maybe the communication channel or whatever is the technically difficult part, if I have a prototype that works, it's great proof that my design on paper is going to work in practice. So, fine, our design is approved. Bring out the computer, it's time to start writing code. We had that really specific technical diagram we got from User Experience, and it's great. And it's therefore quite standard in Android that you may start working on the UI first. So, quick introduction to Android. The UI in Android is made up of a collection of visual elements, layouts and views. And generally these are defined in XML, but they can be instantiated in the Java code at runtime. And by composing these layouts and views together, we can build up the beautiful UIs that you can see on watches and phones. So here I have a small code snippet, a very simple UI. It contains a linear layout which is used for showing items in a line, so either horizontally, left to right, or vertically, top to bottom. So this one's vertical, we have orientation vertical on it. And it contains a single item, which we're going to be showing at the top. And this is a text view. So a very simple view for showing text. It's going to say, hello square world. We package this up in a file which we name main layout.xml. And we pass it to the Android operating system, which will compile this XML resource into an XML file into a view resource, which we can access at runtime. So, when the user taps the launch icon, the first thing that the Android operating system does is call something called my main launcher activity. Activities have life cycles, which Android manages, and the first lifecycle callback that we get is the onCreate method. And so this is the first point in my Android app code that I can run my code after the user has launched my app. So this is the point I want to show the UI. It's very simple. This is what I'm trying to show. Android helps you write these apps. We could call the setContentView method. We call R, which is the static reference to our resources. We know it's a layout, so r.layout, and we gave that file a name, main layout. And this will display our very simple UI. And it looks something like the square screen on the bottom one right here. It says, hello square world. As you see, we're getting now into Android Wear development. Android was first developed as a mobile operating system, so mobile phones. We created tablets, televisions, as I've said. These things had one important aspect in common. They tended to be a rectangle. Come along Android Wear, and we're suddenly seeing that we have round screen as well as rectangles. And you can see on my sample round screen, Android doesn't know that the screen is round. It assumes that it is the larger rectangle that fits around that circular screen. And so this is where the Android wearable support library comes to the rescue. These are libraries and methods to help you develop for Android Wear. And so in there is something called the box inset layout. It's a very clever layout that will allow me to use the same XML file for a square and a round watch face. So, back to my previous linear layout, we wrapped that inside a box inset layout. And then I only need to add one line, this app layout box line. And here I can specify how I want to constrain my UI on a round watch face. I can say top, bottom, left and right, or if I want all of them, I can save keystrokes and write all. And as you can see, this forces a rectangular layout onto a round watch face. And so, while these are very simple, by composing these items together, judicious use of box inset layout, other layouts and views, we can create what are very interesting, beautiful UIs. But it's only UI, there's no content backing it yet. And as I said, my Android Wear device is paired with my phone. And it doesn't have a lot of power itself. It has to get that information from the phone. So how do I send and receive this information? Again, the Wearable Data Layer API comes to the rescue, another wearable API. And this provides a communication channel for my handheld and wearable devices. It's part of Google Play Services, and it creates something called this Wearable Network. So here we have an example network. So Watch 1 is connected directly to the phone via a Bluetooth signal. Watch 2 is connected indirectly using its Wi-Fi signal, and it goes via the cloud node, which is managed by Google Play Services. And then the phone can use its mobile data or its Wi-Fi signal to access this cloud node as well. And together, this creates our wearable network, where the watches and the phone are all the nodes on the network. And using the data layer APIs, I can send and synchronize data between these nodes. And putting listeners on the apps that are on these devices, I can then respond when new information is received. For example, we can use the message API to send information to connected nodes. So when my watch is on and connected to this network, and my phone is on and connected, we can send messages between them. So this is a synchronous communication, and it's great for small, ephemeral, so timely payloads. So we have a really simple example here. For example, perhaps when I start an app or do a particular action on my watch, on my phone, I want to send a message to my watch to start a related app. And so we really are just calling this message API method. Message API sends message, and we pass them 4 things. The first is a Google API client object. This object is our connection to that wearable network. Next, we're passing in a node ID. This node ID references this watch. Next, we've got a path. This path defines the message that we're sending. So we're saying, start app path. And finally, we can optionally include this small piece of data. For example, a string of a document title or a welcome message that we just want to include with this message. Alternatively, we may want to synchronize data between our devices. And for this, we use the data API. So this is for sending information where the nodes may not currently be connected. So it's a form of asynchronous communication. But when my watch does turn on and connect to that network, it will synchronize that data to itself. So it leads to eventual synchronization between all our nodes. And this is also good for larger payloads, such as images. So because we're synchronizing this data, we consider it as a sort of a data map that is stored in the cloud. And this is part of what is controlled by Google Play services. So in order to update the data items, we put in something called a data map request. And here we're having a counter. So for example, every time I do an action on the phone, I want all the connected watches to know that I've done that action 4 times, 5 times. So we create this data map request and we give it a path. Like previously, this time /count. And then we put in this data, it is a data map, and so we use a series of key value pairs. Here, count key, and I just increment the counter to the new value. We put this in the data API, put data item. We give it, like Google API client, this is our connection to the network, and we just put in this put data request. And this will be broadcast onto the network so that all of our watches can pick up this information. On the receiving side, how do I get this information? So I mentioned this Google API client object. This is how we connect. So when we start our app on our watch or phone, we start the connection. And then we receive this on-connected callback. And that's the point when we want to register our listeners. Message API listener and data API listener. And then we will simply receive the correct callback signal on these listeners when there's no information. So we will get this on-message receive event. It comes with a message event, and we use this to check the path. So we're checking the type of message that we sent. We said we wanted to start a new activity. So here we have a small snippet of code to create an intent. This is how Android starts activities, starts apps. And I mentioned that we could pass in a small piece of data. We simply message event.get data. Extract that little piece of information that we sent. For the data API, we get an on-data change call because this is the data that exists in the cloud. We check whether the data was changed or deleted because potentially we may want to do something different. And then again, we check the path that was given. So this time the /count, and we know that this data is going to tell us about the number of times I've done this action on my phone. We check the key, we extract the value, we pass it to this update count method, whatever it is that we need to do. And it works. Basically, when you're developing for Android Wear, these data APIs really abstract away all of the problems of the connections that you have. I've got a Bluetooth connection, or I've got a Wi-Fi connection hopping between intermediate nodes. I don't need to worry about this. I just need to call these methods, and it really does make developing Android Wear apps simple and fun. So now it's ready. I need to make it launch. At Google, we put a lot of emphasis on our quality. So we go through a long series of testing. We first do manual testing. This is done by the Quality Assurance Team, or QA. And we also pass my new feature back to the PM and UX. The product manager is checking that it does the thing we intended it to do, and UX is checking that I fulfilled those requirements of that technical diagram they gave me. We test it thoroughly within our team, and more widely throughout Google in an eclectic process known as dog fooding. And as current or hopefully aspiring Android app developers yourselves, you can have access to some of the same features that we use at Google. So if you have an Android app and you want it to be distributed on Google Play, you will use something called the Google Play Developer Console to distribute your app. And Google Play Developer Console provides you with a lot of features for testing and measuring the performance of your app. So for example, you can use alpha-beta testing. So your alpha and beta testers are people who have signed up to receive early versions of your app. They want to see your new features in advance. They are excited to help you build a better app. And in return, they will give you feedback. For example, they thought it was brilliant, you ship now, or the UI needs some tweaks, or it crashes on a particular version of Android. And once you're happy with your alpha beta testing, it's time to launch. But we do not launch to 100% all of our users straight away. It's very dangerous, it should definitely be avoided. We do it carefully in something called a staged rollout. So we launch, for example, to 5 or 10%. And then we monitor the feedback that we get from our users, maybe the Play Store reviews, or looking for any crashes that we can see in the wild. And the Google Play Developer Console helps you do that. It collects all this information in analytics. You can see where your app is installed on different devices, different Android operating systems, in different countries. And also get feedback on crashes or issues that your users have had. But when you're happy that your launch is going well, you gradually increase this percentage and you roll out to 100%. And then that is your time to sit back and wait for the appreciative Play Store reviews that you have finally done that feature that everyone was waiting for. So I've given a very brief introduction to Android and Android Wear programming. And if any of you are thinking of creating that Android app, please do go ahead and try. And hopefully I've given some insight into the process of how we develop new Android features at Google. Thank you all very much for listening.
So do we have questions? Let's hear it.
Hi, Robin.
Hello.
It's so nice to see all these things. And my question is not, I don't want to offend you, but I have some statistics about Android operating system. So normally, basically, I'm working in cybersecurity. So I told you earlier, 94% Android devices attacked. And this is recent report of vulnerability databases of 2015. And 60% has a malware. But my question here right now, okay, this bad thing is happening, but how software developers know about these things, something bad is because on the back end, vulnerability is induced in your mobile phone due to some bad applications. And your application is affected because you are giving that permissions during development life cycle. Like you are using internet access, all the data contents of your phone and all these things. But then it affects another application. So for example, if other application related to bank or your passwords of saving passwords, your pictures, your content, your Facebook account. But console is not giving information about these things. Like if some malware is happening one application, it affected another one. But console is not giving this information to the software developer, like because of this application, other application is crashed or other application data or permission and authorization data things is leaked out. Did you get my question?
I get it.
Yes.
Okay. So cybersecurity is very important, and it is something that we are all addressing. As I said, I bought my first smartphone 6 years ago, and this is progressing very fast. Technology does move quickly. As you know, the hackers move ever so slightly quicker or slower than we do. We do try and address these things in Android. We have the permissions model that came out in Android Marshmallow or potentially Lollipop, but recently. And this means that your app has to request permissions from the user. So if I want to access the camera, I have to put a dialog up to ask the user, I want to access the camera now, and you are allowed to say no. Also, when sending information between apps, there are restrictions in the Android operating system to make sure that permissions are not passed along. So if you previously granted, for example, your camera app permission to write to storage, which it needs in order to write that camera image, it shouldn't pass that permission on to an app that then views your pictures. So I appreciate this is your research and that there is still far to go, but it is something that is being investigated and that we are always working to try and improve the security of it. So we can talk in front of your research poster to discuss like specific details, But it is something that Android are aware of, and gradually we are trying to do the best we can to make sure that all of our users are safe, as are any mobile and computing operating system.
Thank you.